This is our second installment on trees in Python, and in this version we are going to add the ability to insert a node into a tree. So we have the node class from the previous video unchanged. We have the tree class, which has the init method, and the string class, which are unchanged. And the only thing we've added to the tree class, I say only thing, it's kind of a big thing, is a method to insert data into the tree. And actually, as we insert data into this tree, we're going to be sorting it. Otherwise, you have to have some sort of process for inserting data into a tree. So for example, let's suppose I'm looking at this tree here, which has a node 3, and somebody wants to insert a 2. I have to have some way of deciding where I'm going to put the 2. Am I going to put it on the left or the right? Otherwise, I might as well just be using a linked list. So the most obvious way to do this is to sort the data. The 2 is less than the 3, so I'll put it on the right. If I want to insert a 5, then that would be on the right of the 3 because it's greater than 3. And if I want to insert a 4, that would be greater than 3, so that would go to the right. I would find the 5. The 4 would be less than the 5, so I'd put it on the left of the 5, and we would get this tree. So as we're inserting things into our tree, we're also going to be sorting. Alright, so here is our insert method. We call insert and we have some data. And we go down, we're going to skip the insert method for a second, and we're going to do two things. If the root is none, then we're just going to make the root a node with the data x in it. And if we already have a root, then I'm going to print these inserts as we're going along to show you how things are being inserted into the tree. So I'm going to insert into the root x. INS-insert is a recursive method that starts at a node with the data, checks to see where we're at, and inserts from there. And we're going to do some printing along the way. So I'm going to print out what's in the current node. So this is going to print the value of the data in the current node. Alright, so here's how it's going to go. If we can go left, so if current node.left is not none, and the node in that data is greater than x. So if we are looking at the 3 and we want to put in a 2, we're checking to see if 2 is less than 3. Now in the case where we're going to go through this in more detail later. So if we can go to the left and our x is less than the node we're currently at, we go left. So we insert and then we go to the left, current node.left. Otherwise, if we can go to the right and x is greater than the current node data, then we go to the right. So we insert on the right node. Now, here's where, so this is the recursive part. We're just traversing the tree here at this point to find the right node. These two things mimic these, but the difference between these two if statements and these two if statements is this is where we're actually going to insert a node. So, at this point, our current node.left is none, but the data is greater than x. So let's go back now and look at our tree. So we put in 3 at the root, and we want to insert a 2. So we look at this thing, and the current node.left is none, and 2 is less than 3, so we insert the 2 to the left of 3. And the way we do that is we set current node.left equal to node of x. Otherwise, if the data in the current node is less than or equal to x, and you have to have an equal sign on one of these. It doesn't matter which, but you got to put it on one of them. Then we insert it on the right by saying current node.right equals node x. So, whoops, I brought up the wrong one. In this case, when I want to insert the 5, then I put the 5 on the right of the 3. 5 is greater than 3, so the 5 goes to the right, and current node.right is 5. Then, when I want to go to insert the 4, we start at the root. We check is the left none. It's not, but 4 is greater than 3. So we skip this. So current node.left is not none, but current node.data is less than x, so we don't use this if, so we don't traverse to the left. Current node.write is not none, and current node.data is less than x, so we actually go insert. We call insert to the right and we traverse to the right. So in this case, 4 is greater than 3, and we can go to the right, so we go to the right and we find this node, and now we're calling insert, that insert method, with node 5. And looking at node 5, we check is current node.left none. Well, actually, when we're inserting the 4, the current node.left is none. So we skip that. Current node.right is none, so we skip that. We come down here. If current node.left is none, and at node 5 it is, and current node.data is greater than x. All right, so current node.left is none, and current node.data 5 is greater than the 4, so we put the 4 to the left of the 5 by saying current node.left equals node of x. So the left branch for 5 is going to be a node with 4 in it. All right. Now I'm going to build a tree. I'm actually going to build a different tree here than the one I have here. I'm going to build a tree that looks like this, where the root is 2, and then go 2, 3, 5, 4. So I'm going to insert a 2 first, a 3 first, a 3 second, then a 5, and then a 4. And I'm going to print these at different stages. So when we start with a 2, we actually get a different tree, and that's part of the reason why I did this, starting with a different root than what I was illustrating here. Depending on what you insert first, you get different trees, but they always print out in the same order. When I do 2, 3, 5, 4, I'm going to get a tree that looks like this. This is the root. The 3 is greater than the 2, so it goes to the right. The 5 is greater than the 2. It's greater than the 3, so it goes to the right of 3. The 4 is greater than a 2. It's greater than a 3, so we go to the right to this node. 4 is less than 5, so it goes to the left, and we get a tree that looks like that. But when we go to print this, let's see what happens. All right, so x.insert 2. We come up here, the root is none, so we set the node equal to x, and we print off the entire tree x, which only has a 2 in it. Then we insert 3. So now self.root is not none, it's got the 2. We print inserting 3, and we go to insert with x. We print the current node, which is 2. Current node.left is not none, but current node.data is greater than x. It is false because 2 is not greater than 3. So we don't do this. Current node.write is none, so we don't do this. It's this one we need to check. Current node.left is none because we so far have only inserted the root 2. But current node.data is not greater than x. 2 is not greater than 3. So we skip this. Current node.write is none, because again, we're at the root 2. And current node.data 2 is less than or equal to 3, so we set current node.write equal to node x. So it says inserting to the right. We put the 3 on there, and then we're done with that insert. And we print off the entire tree, and we get 2, 3. Now we insert 5, so we're going to insert the 5, and when we insert the 5, again, the root is not none, so we go to inserting, and we say inserting 5, and then we go to the INS. That prints the current node, so we're starting at the root 2. All right, so current node.write is not none, because there's a 3 there, right? And the current node.data, which is 2, we're at the root, is less than 5, so we do this. We go right. And we call insert with current node.write. So now we're calling insert, whoops, wrong tree. We're calling insert with this node 3. And at this point, these are the only two nodes in the tree, 2 and a 3. So current node.left and current node.right are both none at this point. So we skip these first two, and we go down here. We look at current node.left is none, but current node.data, which is 3, is not greater than 5, so we don't do this. Current node.right is none, and current node data 3 is less than 5. So we insert to the right, and we put current node.right equal to node of x. Oh, and I guess I think I may have missed this. You can see where we printed the 3 when we went to node 3. Okay, inserting 4. So we're putting a 4 onto this thing. And it's going to go pretty much like before. So we call this with 4. We are inserting 4. We come up here, we start with a root. Can't go to the left. We can go to the right, and current node data 2 is less than 4, so we go to the right. So we say going right. Now we're at node 3. That node, current node.right, is not none because there's a 5 to the right of it, and that data 3 is less than 4, so we go to the right again, and we end up at node 5. So now we, whoops, wrong tree. We go 2, 3, 5. We're here. At this point, this doesn't have any left or right nodes, so now we're going to go into these two things. And current node.left is none at node 5, and the current node data 5 is greater than the 4, so we insert to the left, and we add that node 4 on, and now we've constructed, whoops, I keep doing that, we've constructed this tree. And when we print this, print 2, 3, 5, 4 using the same print method we had before, which goes to the left, then visits, then goes to the right. So from the 2 you go to the left, there's nothing there, you print the 2, then you go to the right. At 3 you go to the left, there's nothing there, you print the 3, then you go to the right. At 5 you go to the left, you get 4, there's nothing to the left or right of that, so you print the 4, then you come back to the 5 and you print it. 2, 3, 4, 5. It doesn't matter how you build this tree. The way we're inserting things, we're inserting them in an infix way, so you can build the tree any way you want. The tree I started with when I first did this was 3, 2, 4, 5, right? So if I switch the order of these and make this insert 3 first and then insert 2, the way things are inserted change, and I'm going to end up with the tree I had initially. This one, the 3 is now the root, but when you traverse the tree, you still get it in order. So how the data is inserted and in what order the data is inserted determines some characteristics of the tree, but in the end, when you print it using this string method, it's going to be in order. Well, assuming that I also build the tree this way, using these less thans and less than or equals. Alright, so I mentioned this in a previous video, but it might be worth checking out because you've got the code up on GitHub. What happens if I change the order of these things around? What if I take this if, this is in the string method, and put it there, or put it there? Well, not inside the if, but what if instead of going left, then printing, and then right, if I go left, go right, then print? So those are things, I personally, if I were you, I mean, you can just copy my code and run it and see what happens, but it's a good exercise. You should be able to do this by hand. Take this thing, put it up here as the first if, and just take a small tree and try to traverse it by hand and see what you get. Do it by hand first, and then see if you get what the code does. You can run the code. It's on GitHub. You can copy and paste it into your own version of PyCharm and run it. So try it. See if you can do it by hand. It's a good exercise to try.